Hi guys, today we're jumping into a bit of a different topic than we've talked about before, and we're going to be talking about the GCF, or greatest common factors of monomials. And just a reminder, though, that a factor really means that it's an algebraic number or an algebraic expression that will divide into these terms evenly and will have no remainders. So we're trying to find that common factor between 4a to the second and 6a to the third, that greatest common factor. And the way I like to do it is I like to first pay attention to the coefficient. So we got a coefficient of 4 over here and a coefficient of 6 over here. And let's first make some factor trees. Just a reminder, a factor tree is we are multiplying together things that multiply into our coefficient, and we are going as far as we can. In the case of a factor tree of 4, 2 times 2 is equal to 4, and this is as far as we can go. We cannot break down 2 any further because the only thing that evenly multiplies into 2 is 1 and 2, and it wouldn't make sense to keep going. We could go forever and ever that way. We're going to do the same operation over to 6. So I know that 2 and 3 multiply into 6. So we have successfully created the two factor trees for our two coefficients. Then I like to list out and pay attention to those variables next. So let's go ahead and factor as far as we can 4a to the second. We know that it's equal to 2 times 2 times a times a. A to the second is just a times a. And then we're going to go ahead and we're going to do the exact same thing to 6a to the third. I know that it is 2 times 3 times a times a times a. Now, looking at the totally factored out versions of 4a squared and 6a to the third, our job is to find the commonalities between these two things. The commonalities. I know, looking at our list here, I know that they both have a 2. Now, 4a to the second doesn't have a 3, and 6a to the third doesn't have an additional 2, so we can't include that. But they both have an a, and they both have another a, okay? So therefore, I know that the GCF, or the greatest common factor, is going to be it's going to be 2a to the second power. 2a to the second power. Oh, we got a little topsy-turvy. 2a to the second power is the largest factor that can be multiplied into both 4a squared and 6a to the third. Let's go ahead and do another example with a little less topsy-turviness. Let's go ahead and do 8x to the third and finding the greatest common factor with 12x. As always, let's go ahead and factor these coefficients first. 4 times 2 is equal to 8. And now this 4 can be taken a step further. 2 and 2. So I know that 2 times 2 times 2 is equal to 8. Let's make a factor tree for 12. 6 and 2 multiplies into 12. We're going to take that a step further. 3 and 2 multiply into 6. So I know that 2 times 2 times 3 is equal to 12. What I want us to see here, I'm not even going to list it out. I'm going to take a quick little shortcut here. I see that there is a pair of 2's in each of our factor trees. 2 times 2 is equal to 4. Now, I know that our GCF is going to include a 4 in there. If I were to divide both 8 and 12 by 4, we would end up with an even remainder. Now let's talk about our variables. What I want you to see is that these are univariate. We're only dealing with an x here, so we don't have to worry about anything else. But this one has x to the third, and this one has a single x. Remember that invisible exponent is 1 right there. A shortcut to finding the GCF is take the smaller of the exponents. That is your GCF. We can only divide out a single x from this guy, this 12x, which means that we can only pull out a single x from this as well. Our GCF then is just 4x. Awesome job, guys. I'll see you tomorrow.